netizens, back with me again, Aji Gautama Putrada. I am a lecturer for Para and Distributed Systems. This is our 11th meeting about shared memory model or thread. In the fourth video, we will discuss about base condition. So we have discussed about threading, and now we are going to discuss about the problems. So when we talk about threading, it means that two parts of the program are running at the same time, minimum two parts, and what they can do is they can use the same variable, use a shared variable, just as we said that this is a shared memory model. And when they use a shared variable, there is a problem that arises, which is race condition. And race condition is a problem that needs to be solved. So let's explain first what race condition is. So for example, here we are back in our illustration of a shared memory. So here, for example, we have two CPUs that are running at the same time. CPU 1 is running thread 1 and CPU 2 is running thread 2. Both of them use the same variable, which is A. So one uses A and thread 1 uses A, and also thread 2 also uses A. And imagine a program that has a sequence of program. For example, thread 1 gets A, and then it needs to operate A and then print A. And then in those three steps, what happens if between operate A and print A, there is a interruption by thread 2. It means that when it operates A and prints A, it prints the wrong result because thread 2 also operates with A. And to give you more imagination of the problem, like before, we need to create an example program. So here I am going to create an example program that shows that this is a problem of race condition. So this is our program, and what's the difference between the program before? Here we have a new variable called y, and then we have two different threads now. The first thread is incrementing and the second thread is decrementing. So what incrementing do is like the name, it increments y here, and what decrementing do, it decrements y. And before it decrements or increments, it prints incrementing and decrementing. But before it increments or decrements, it goes to sleep. Yeah, with a variable with between 1 and 10. And what happens if we execute this program? Let's see. So here is the result of the execution. Do you see anything funny here? Well, if you see closely, there is something that that is wrong. So here it says that it is decrementing, and it becomes -1, and this is correct. And it says again it is decrementing, and it becomes -2, and this is also correct. But here it says it is decrementing, but the variable becomes -1, which this is incorrect because it should be -3. So why does it happen? Why does this happen? Because when it says decrementing and then it goes to sleep, the function incrementing um, uh, takes place, and it adds y with 1, and then it prints the y before the decrementing is awake from its sleep. The result is it says it is decrementing, but the value is minus 1. So this is what we call race condition. And how do we solve this? We will discuss it in the next video. It is called synchronization. So that is the end of video 4. In video 4, we have successfully discussed about race condition. In the next video, we will discuss about synchronization techniques. Thank you for your attention and meet you in the next video.